Hello,
Hello, sir.
how are you?
Fine, sir.
Okay. So, in that from last class?
Last, sir, Archimedes principle.
Okay. We have started this. Suppose any object which is kept in air initially, so it will have some weight like this. When it is immersed in fluid like this, so it may have some amount of volume outside and some amount of volume immersed into it inside. So Vi is its immersed volume and V naught is its outside volume. So how much volume of this particular object immersed in this particular liquid, it will displace that much amount of liquid. And according to displaced liquid, it may experience an upthrust, which is called buoyant force. Is it clear?
Yes, sir.
Let me give you a question how to calculate these two terms. A cube having side 10 centimeter, density 0.6 gram per centimeter cube. On emerging if in water it is 3 centimeter outside, so find weight of object and second buoyant force experienced by it. Let me give you a hint how to solve. Suppose you have cube of side 10 centimeter like this. In which 3 centimeter is in air. So this will be layer of liquid up to this part. And rest of the 7 centimeter is inside. Is it clear?
Yes, sir.
Then try to find these two terms according to this. Harsh, any problem while solving?
Uh, so can I solve this?
Okay, let's say for weight will be equals to mass times gravity.
Yeah.
If you convert mass in terms of volume, it will be sigma volume gravity. We have sigma as zero point 0.6, but in terms of gram per centimeter cube, so just multiply it by 10 to the power 3 to convert it kg per meter cube. Okay. Since this particular term object is cube, so its volume will be length, breadth, and height.
Height. Yeah.
Gravity is 10.
10.
So just count number of zeros in numerator and denominator. So we have 7 0 in numerator and just 6
Yeah.
0 in
So
denominator.
in denominator, yeah.
So you're left with 10 to the power 1 and 0.6. So on multiplying, you will get 6 Newton.
6. 6 Newton.
Okay. Next, since this body is immersed up to 7 centimeter in this liquid, so Bowen force will depend upon how much liquid it would displaced, or you'll say how much volume of object is immersed into that liquid. So it will be density of liquid, volume of object
Volume
immersed times
and
gravity.
gravity.
So density of liquid is water, 10 to the power 3.
Yeah.
Volume of object immersed is length,
Into
breadth.
breadth. Into height.
So for height, how much will take?
7.
Good.
Yeah,
7 by
yeah.
100 into 10. Now just count number of zeros in denominator and numerator.
Denominator, so 6 zeros and numerator 6. Yeah.
So you're left with 7.
Yeah.
Is it clear?
Yes. Yeah. No, sir. Yeah.
Okay.
I was just like.
Now let me define you for equilibrium condition. For equilibrium, it means Barn force equals to weight of object. So Barn force is density of medium, volume of object immersed times gravity.
Yeah.
Weight is sigma volume gravity. So gravity and gravity cancel out. So you're left with volume of object immersed by total volume equals to this by this. Now using this relation, let me define you some concept. There will be 3 different cases related to this expression. First, there is a vessel in which liquid is at up to this point. Like this. So in first part, when a body is immersed and it may attain a configuration like this. So we can say for this part, volume of object immersed is less than its actual volume or its total volume. Is it clear?
Yes, sir.
So the ratio of VI divided by V will be less than 1. And since this particular term is equals to sigma by rho, so you will say sigma will be less than rho, or weight of object is less than Barn force. Is it clear?
Yes, sir.
So it will tend to float on liquid by partially emerging and partially outside. So it will float. In second part, suppose having configuration like this, completely immersed. So volume of object immersed equals to its total volume. So sigma will be equals to rho, or weight of object will be equals to buoyant force. But still it is floating. Let's say in third part at this point. So in this case, we can say volume of object immersed is greater than its actual volume. So sigma will
Yes.
be greater than rho and weight will be greater than buoyant force.
Point force.
So in first two cases, we can say it will have tendency to float, and in this case, it will sink. So you'll be asked what would be the condition for floating of a body. So you'll say weight and buoyant force must be related like weight either less than or equals to buoyant force. In this case, it will tend to float. And if a weight exceeds buoyant force, object will get sink. Is it clear?
Yes, sir.
In first part, it is floating with partially immersed. In second part, it is floating with completely immersed. Okay, just write it down.
Yes. Done, sir.
Okay, Now let me define you question related to this part. If 25 liters of ice having density 0.9 gram per centimeter cube is an ocean, find volume of ice in air and inside water. What fraction or what volume of ice will be in air and what volume of ice will be in water? So how to calculate? So you will say this will be the case of floating condition. Ice will tend to float since it having density less than water. Is it clear?
Yeah.
So we can say volume of object immersed by total volume must equals to sigma by rho.
Sigma by.
Vi is how much volume of ice that will be inside water, and B is total volume of ice. Rho is or sigma is density of both these two objects. So you have sigma, that is density of object, which is ice, that is 0.9 gram per centimeter cube, and rho is water, which will
Water.
be 1 10 to the power 3 meter per kg per meter cube. Now, using this, you'll be able to calculate volume of object immersed, and then total volume equals to volume of object inside plus volume of object outside. Then you'll get total volume of ice that will be in out of water. Is it clear?
Yes, sir.
Try to find.
Sir, can you repeat what is rho?
Rho is density of medium in which object is kept. Okay.
Yeah. Okay. Density
And
of
sigma
medium.
is
Okay.
rho is density of water,
Yeah.
and sigma is density of object.
Yeah. Density of object.
Harsh, you got the answer?
Sir, I tried to solve it, but I guess I'm getting some calculation mistake.
Volume of object immersed we have to calculate. What is the total volume here? 25 liter.
25 liters, yes.
Sigma is density of object, that is zero
Zero
point
point
0.9
9 gram.
into 10 to the power 3, and
Yeah,
density of water is just 10 to the power 3.
yeah,
Okay, so Vi will be equals to 0 0.9, 10 to the power 3, 10 to the power 3 will cancel out.
yeah,
Move
yeah,
this 25 to right side like this. So 25 into 9, it will be 225. With one decimal, it will be
yeah.
2.5 liter. Is it clear?
Yes, sir, I got the correct answer. Yes.
Good.
Yeah,
So volume of object outside water will be total volume minus volume of object immersed into it. So it will be about 2.5 liter.
2.5 liters. Okay, sir. Yeah, got it.
Okay. Further, related to this problem, you will be asked what would be the percentage of volume of object that will be outside of liquid, inside of liquid. So just use this fraction and multiply it by 100. You'll get percentage of volume of object inside or immersed into it. And then on subtracting from 100, you'll get the rest part, that is volume of object outside the liquid. Is it clear?
Yes, sir.
So this is all about Archimedes principle and its term to calculate power and force and weight related to this part. Next is surface tension. To define this surface tension, let me give you some idea about molecular interaction. In general, we have two different types of molecular interaction. First is called adhesive force and second is called cohesive force, or force of adhesion or force of cohesion. So what do you mean by adhesive force and cohesive force? Adhesive force is force of attraction between particles of different matter or interaction between different particles. Similarly, cohesive force is force of attraction between particles of similar type or same type. Is it clear?
Yes, sir.
So force of attraction between particle of different type, and this is force of attraction between similar particle. Now, related to these two force of attraction, let me define you. Suppose in a vessel, if liquid is up to this level, like this. So at any instant, let's say at this point, if you assume any cross section, in which suppose there is a particle of liquid at its center, this one, surrounded by particle at its neighboring edge at this, this, and so on. So if I define the interaction between these particles, so you'll say there will be force of attraction this way, and all are due to force of cohesion or cohesive force, since this is attractive force between similar particles. Is it clear?
Yes, sir.
So you'll be asked, what would be the net force at the central particle in this condition? You'll say 0, since total outward force or total upward force counterbalanced by total downward force, or total right side force counterbalanced by left hand side force. So in this case, net force experienced by that central particle will be 0. Is it clear?
Yes, sir.
Now suppose a layer at its topmost point, this one. In this part, we have liquid, and this, which is interacted by its neighboring particle along this way. So if you have to calculate net force on this centralmost particle, will the net force in this condition on the centralmost particle be 0 or not? For this condition, you will say no, since
Mm.
there is no any particle
On
above to this
the,
particular layer,
yeah.
which is counterbalancing the force due to downward particle.
Yes,
So
sir.
you'll say they will have some net downward force to this particular particle. So net force in this condition will not be equals to 0. Okay.
Yes.
So this will be the case of all particle which is existing at the top surface of this liquid. Is it clear?
Yes, sir.
So let me define you. What do you mean by tension? You must have learned about tension in chapter 5th, laws of motion. Do you have any idea what do you mean by tension?
Tension.
Suppose you have a wire
Yeah.
which is hanged freely by any vertical support, let's say. So due to its slackness, tension in this condition will be 0. What do you mean by tension? So if you exert some force, or if you attach any object at its lower end,
Then it has
like this,
tension.
so this string may get straightened. Okay.
Yeah.
So due to its straightness, a force will develop into it, which is called tension. Okay.
Tension.
So in this part, you'll have some downward force due to gravity. So they'll have some straightness to this object or this string. So a force will develop into it along this way. This force, which arises due to its straightness, is called tension. So tension is a force due to straightness of a particular wire, rope, or string. Similarly, in this part, for this top layered liquid, we can say there is some net force which tries to keep it downward or slightly outward. So it will have some stretched membrane behavior like, is it clear?
Yes, sir.
This tendency of top layered liquid is called surface tension. And why it is arising? Due to its molecular interaction with its neighboring particle. Is it clear?
Yes, sir.
So surface tension is the top layered liquid behaves as a stretched membrane due to its molecular interaction. This behavior is called surface tension. The top layered liquid film or thin layer behaves as stretched membrane due to its molecular interaction. This tendency is called surface tension. Any doubt, Harsh?
No, sir.
Okay, just write it down.
Yes.
Yes, Harsh, do you want to ask something?
No, sir. So, sir, what is before as stretched?
Behaves as a stretched membrane.
Oh, behaves as stretched. Done, sir.
In general, you'll say the surface tension acts tangentially to the interface of two separating medium. When there will be any two separating medium or interface, surface tension acts tangentially to that interface. I will define you later what you mean by this. So we can say it acts tangentially to the interface of two separating medium. Next, surface tension proportional to cohesive force. Greater the force of cohesion, it will have greater the value of surface tension. Inversely proportional to force of adhesion or adhesive force. Inversely proportional to temperature. If you increase temperature of liquid, surface tension of liquid decreases.
decreases.
Next, inversely proportional to spreading out tendency or spreading tendency of liquid. So more the surface tension of that particular liquid, it will have tendency to coagulate or minimize surface area. So it will have least tendency to spread out. Is it clear?
Yes.
Next, inversely proportional to impurity added to that particular liquid. If you add any impurity to any particular liquid, its surface tension decreases. So these are some terms on which surface tension may depend upon or on which may define its application. Is it clear?
Yes, sir.
So on the basis of this behavior, you will be asked in physical, what surface tension do actually? So you'll say it will tend to coagulate any particular object to acquire minimum surface area. Hence, you'll be asked why all objects tend to acquire spherical shape. So you'll say, since for constant volume or for same volume, for all 3D figure, spheres will have least surface area. So it will have least energy. So it will be most stable. And how it will tend to acquire spherical shape? So you'll say it is due to surface tension. Okay.
Okay, sir.
We will calculate this particular term in later on. Okay. Till
Yes.
this, just write it down.
Done, sir.
There will be one more thing. It will be also inversely proportional to wetness of surface. Whether a particular liquid having ability to wet the surface or not, it will depend upon their surface tension. It will have smaller surface tension, it will wet that surface. It will have, if it will have larger surface tension, it won't wet the surface. Suppose
Sir, so water has more like less surface tension.
on interacting with any particular solid object on which it is placed. Let me define you. Suppose surface, surface. In first case, if water is dropped, so it may acquire shape like this. But in case of mercury, it will tend to acquire this. So as surface tension acts tangentially to the interface, so in this part we have first interface along this way between liquid and air. So surface tension between liquid and air. Second interface is at this point between solid and liquid. And third interface is at this point between solid and air. Is it clear?
Yes, sir.
Similarly, in this part, there is one interface at this point between liquid and air, this direction between solid and liquid, and this direction between solid and air. So the angle in between them at this point, theta, theta is called angle of contact.
Angle of contact. Yes, sir.
So we can say using this for the left part, this water having surface tension and small magnitude. So it will have large force of cohesion as force of adhesive force as compared to cohesive force. So it will have tendency to spread over that particular surface. So easily spread out. And can wet the surface. But in second case, for mercury, since its surface tension is large enough, so it will have stronger force of cohesion as compared to adhesive force. So can't spread out. And similarly, it can't wet the surface. So wetness of a particular surface will depend upon its surface tension or force. Is it clear?
Yes, sir.
Okay, just write it down. So in first part, theta or angle of contact is acute, and second part, theta or angle of contact is obtuse.
Done, sir.
Okay, there will be question related to this. Why we use detergents with water to wash clothes. Any idea?
Yes, sir, because like water have left surface tension, they can spread over the thing.
No. Initially, without using detergent, water will have large surface tension. So it can't wet that dirt easily. So it won't be able to cleanse it or wash it. So on using detergent, we are using some impurity to that particular liquid. So
Yeah,
on using any impurity, surface tension of it may
decreases.
decreases.
Yeah,
So on decreasing surface tension, it will have ability to spread over that dirt easily and cleanse it and wash it. Is it
okay.
clear?
Sir. Yes, sir.
So we can say on adding detergents, surface tension of water decreases. So it will easily spread over dirt and can cleanse it and wash it. Hence, we use detergent along with water. Any doubt?
No, sir.
Similarly, next question will be why we prefer hot soup or why hot soup feels better in taste as compared to cold one. Any idea?
Sir, because of temperature, sir.
Good. So you can say hot soup will have higher temperature.
Yeah,
So
so
higher
the surface
temperature
tension
will get,
decreases.
yeah.
Surface tension decreases.
So then since our tongue consists of taste buds at different position,
Yeah.
okay.
So it can
So if
spread
that,
out.
yeah. So if that soup having ability to spread over easily to entire tongue, so it get encountered with each different taste bud and it will feel much better in taste.
Yes, sir.
That's why we prefer hot soup instead of cold one. So since hot soup having high temperature, so lesser surface tension, so can easily spread over entire tongue and get interacted with different taste buds. Hence, feel better in taste. Any doubt?
No, sir. Done, sir.
Okay. There will be another question. Why mosquito will be able to walk on water surface or surface of water? So you will say its surface tension on that particular water will be more or less.
On the surface of water,
It will have
it will
some
be
large,
more.
yeah, it will have some large surface tension that will be capable of uplifting the entire body weight of that insect so that it will easily float or walk on the surface of liquid. Is it clear?
Yes, sir.
Let me define you one more thing. In last class, I defined you one thing, wrongly described you. This part. There was a question, what would be the pressure in vertical position at head and at its toe? So you'll say, since air is all around us, so they will have atmospheric pressure on head as well as toe.
Yeah.
And there is no
Sure.
much difference in height for these two different liquids, for these two different positions. So you'll say P naught and P naught from outside will be same. So there will be difference from inside. Let me define you. Just 1 minute. So the pressure on head and toe will be due to the blood flow or the accelerating blood into that particular point. So let's say this is position of heart, which is pumping blood throughout our body. So it will have some small length of blood stream up to this point and will have longer length of blood stream to reach at this point. Is it clear?
Yes.
So from inside, blood pressure at head, since it is defined by some smaller length of blood flow, so it will have lesser pressure as compared to this bottom point.
Sure. Yeah.
That's why pressure at toe will be greater than pressure at head.
Yes, sir.
Okay, so just correct it.
Okay, sir.
Longer length and will have some shorter length of blood capillary.
Done, sir.
Okay. So any doubt in this part in surface tension?
No, sir.